We've been looking at functions this chapter. Today we're going to be looking at square root functions and square root inequalities. The first one we're going to look at is the function x squared. And we've looked at this type of function first try when we talked about quadratics. This is a quadratic. When we graph it, which we will do in a little bit, we should get a parabola. What we're going to do first though is find the inverse. Remember yesterday we said inverse, you want to switch the x and y values around in order to find an inverse. F of x is like your y, so if we switch x and y here, we get x equals y squared. What we want to do now is solve that for y. To undo this power of 2, which we need to get rid of, we take the square root. So if we square root both sides, which we're going to do, we're going to end up with y equals, and when we take square root, in this case, it's always going to be plus or minus the square root of x. And so our inverse function, if we read it with the inverse notation, would be plus or minus square root of x. So that would be the inverse. What we're going to do next now is graph both the original function, f of x, and the inverse of f of x on the same coordinate plane. Let's start with just x squared. We've looked at that graph before. You could just plug in numbers to do this. We could use calculator to help us out too. Let's graph that one out. If we graph it, y equals x squared. We can see the graph is going to be a parabola. If we want some values, we can go to our table, and we see some numbers here that we could put on our graph. So there's a point at negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. Whatever number you plug in for x and square it, that should be the y. So looking at those points, we'd have 0, 0. If you put 1 in, 1 squared is 1. If you put 2 squared in, it's 4. If you put negative 1 times negative 1 is positive 1. Negative 2 times negative 2 is positive 4. So the graph of f of x looks like that. Now let's graph the inverse. If we graph the inverse, whatever number we put in, we want to take the square root of. So if we put in 0, square root of 0 is 0, and it would be plus or minus that, so it's just 0. If we put 1 in, square root of 1 is 1. So when we put 1 in for x, the result is positive 1, but it's plus or minus, so it also could be negative 1. If we put in another number, let's try like 4. If we put 4 in for x, square root of 4 is 2, so it'd be positive or minus negative 2, positive 2 or negative 2. So the inverse is also a parabola shape that's just opening to the right instead of up. Notice that these two are inverses of each other, and we said inverses are always, if you graph a function and its inverse, it's always going to be a reflection over the line y equals x. So you can see both our original function f of x and our inverse function are reciprocal, or are reflections of each other over this diagonal line. We're going to be looking in particular today at the square root part of this, the inverse right here. This is the graph of square root of x that we're going to be looking at today. All right, let's go down to the second problem. On this one, they also want us to graph this one out. There's a little table provided for us. We want to plug those numbers in and see what we get. So you can just simply take your numbers, plug them in for x, see what you get, and write the result here. Or you can use technology to help you. Let's use our calculator to graph again. So if we insert this function, square root of x plus 2 we can bring up the table and get the values here. So if we bring up the table, now we have the values to fill in our thing. Notice the first one there, -3, the calculator says error for that one. And it should. If we put this number -3 in for x, -3 plus 2 is going to end up equaling -1. And if we do square root of negative, it does come out to be a, it doesn't come out to be a number that is not real. It's an imaginary number. All right, so let's write those in. This one's not available. If we look at the rest of the table, we got -2 is 0, 1. This one instead it was about 1.4, and this one came out to be about 1.7. So let's graph those out. -2, 0 is here. -1, 1 is here. 0, 1.4 is about there. 1, 1.7 is about there. And we can kind of see the pattern that's going here. If we look at just one more number, it looks like at 2, the value is 2. So we could graph that one too. 2, 2 is a point. And you get kind of that sideways parabola looking graph. Now, this one does want us to answer some questions. What is the x-intercept, y-intercept, domain, and range? X-intercepts where it hits the x-axis. So if we look, our graph here hits the x-axis right there at -2. What's the y-intercept? The y-intercept's where it crosses the y-axis right there. If we look at our table, it looks like it was about 1.4, something about there. Domain and range. Remember domain and range? We've been talking about that again this chapter. Domain is your x's, range is your y. So what is the x values that this graph can have? If we look back at our table, does -3 work? No, -3 is not in the domain. It looks like our domain starts at -2. At -2, that x value, now we can start getting values, and anything bigger than -2, we have a value 2. -2 is the first x value here, so the domain is all the x's greater than or equal to -2. Our range is our y's. So what is the lowest y value we see at the same point? Right here. Our lowest y value is 0, and it's anything bigger than that. So our range is everything greater than or equal to 0. All right, so we're going to be doing some more of these graphs of square roots. How do we get domain and range maybe a little bit quicker where we don't have to get a table, make all the points, graph it in order to see it? To find the domain of a square root function, what we can do is set the radican's the part underneath the square root, greater than or equal to 0 and solve for x. So a quick way, and you can write this on your note sheet, to find the domain of a square root function, set the radican greater than or equal to 0 and solve for x. Let's look at two examples you have on your note sheet. This first one, if we want to find the domain of y equals square root of 4x plus 2, take the radican, that's the part underneath the square root, set it greater than or equal to 0. Because we know anytime you're doing a square root, the lowest number you can take a square root of is 0. If you try taking square roots of negatives, you get imaginary numbers. So we want to solve this and see what we get for x. Well, if we're going to solve it, we'd want to subtract 2, divide by 4, and if we take -2 divided by 4, we get that x has to be greater than or equal to, -2 divided by 4 is going to give us -0.5. So that would be the domain. It has to be greater than -1/2. Let's look at another example. On the second one you got on your sheet, again, take the radican, the part underneath the square root, set that greater than or equal to 0. Because again, 0 is the lowest number you can take a square root of. Solving that, add 3, divide by 2, and if you take 3 divided by 2, you're going to get 1.5. So here the domain would have to be that any x value greater than or equal to 1.5. All right, so that's domain. How about range? How do you find the range of a square root function? The range, you just want to look at the number after the radical or after the square root. So whatever this number is, that's what's going to tell you what the domain's going to be. So when there's a number there, then it's just that y is going to be greater than or equal to whatever that number is. Doesn't matter what the c number is, that's what your domain's going to be. So in this case, our range is going to be y is greater than or equal to whatever this number c happened to be. If it's 5, it's y equals greater than or equal to 5. If it's 10, it's y is greater than or equal to 10. Now, a lot of times you're going to see a number there, but it might happen that maybe there's not a number there. Then what do you do? If there's not a number there, then we know the number really is like plus 0. So then the range would be y is greater than or equal to 0. So if you don't see a number, then it's y is greater than or equal to 0. Let's look at a couple examples again. We already looked at these two just a second ago. Found the domain. What's the range going to be? For this one, we want to look after the square root, after the radical. Is there any numbers being added or subtracted out here? No. So that's the case we just talked about. If there's no numbers, it's going to be y is greater than or equal to 0. That would be our range. All right, let's look at the next one that we did before we found the domain. Is x is greater than or equal to 3/2 or 1.5? What's the range? Do we have a number added or subtracted after the square root, after the radical? In this one, we do. So the range is y is greater than or equal to whatever that number is. Here, it's positive 4, so 4. That would be the range on this one. So range is very quick. You just have to spot and look at the numbers, see what it is. All right, so we're going to do one more example here where we're going to graph out a square root function. Let's kind of do what we've been doing in the last couple. We're going to find domain and range first. So domain, we want to take the part underneath the square root, the radicand, put that greater than or equal to 0 and solve it. All right, on this one, to solve that, looks like we got to divide by -2. I put this one on here because it kind of brings up a point about solving with inequalities greater than or equal to, less than or equal to, or greater than or less than. Anytime you divide or multiply by negative, we got to remember to switch the signs. Here we're dividing by -2, we got to switch the direction of the sign. 0 divided by -2 is 0. So our domain on this one is x has to be less than or equal to 0. Let's look at our range. What's our range going to be? Look at the number after the radical, after the square root, positive 3. So here, y's got to be greater than or equal to 3. So our range, y is greater than or equal to 3. If you look at these two numbers, 0 and 3, that'll always tell you, the domain and range will always tell you the first point to graph if you're looking to graph it as well. 0, 3, 0 being the x, 3 being the y, that's the first point. If you want some more points after that, then you want to just pick x values bigger than that and see what the y value is. So you can plug in 1, see what it equals. Plug in 2, see what it equals. And this is, again, where you could use a calculator to help you out and see what those values are. So you could put it into the calculator, look at the graph, and see what it is. Putting this one in, we got the square root, -2x. Close the parentheses, plus 3. You can graph it, or you can get a table to get the numbers and look at this one. Now this one, if we put those numbers 1, 2, 3, looks like we went the wrong way because this one actually is going, this one says less than 0 down here. So we would actually want to pick numbers less than 0. All right. We'll continue graphing this one. If you want to try graphing the rest of this one, We will graph it, the rest of it in class, and look at more square root functions tomorrow.